This video will cover difficult questions regarding the topic of limit with the square root in the 0 over 0 form. This is the first question. Let's use substitution. Let square root of x be a. When you square each side, you get x equals a squared. And as x approaches 1 over 9 is same as a approaches 1 over 3, because square root of 1 over 9 is the square root of 1 over 3 squared. That is 1 over 3, which is a. Then change every x into a. So limit as a approaches 1 over 3. So 1 minus 9x is the same as a squared over square root of x equals a. So a minus 3a squared. Then you can factor the numerator. This is a squared minus b squared form. So it can be 1 minus 3a, 1 plus 3a. And then we can take out a to get 1 minus 3a. And then cancel the common factor. So limit as a approaches 1/3. So 1 plus 3a over a. And then put 1/3 into a. So 1 plus 3 times 1/3 over 1/3. So it's 1 plus 1, which is 2 over 1 over 3. And then make a fraction, 2 over 1 over 1 over 3. So it's outside over inside. So answer is 6. This is the next question. This question uses the same technique as question 1. Pause the video and see if you can solve it yourself. Once you're done, come back and we can go through it together. Did you figure it out? Let's check it together. Let square root of x be a. Then square each side. We get x equals a squared. When x approaches 1 over 4, it is the same as a approaching 1 over 2. Because square root of 1 over 4 is same as 1 over 2. We can rewrite the limit as a approaches 1 over 2, 4a squared minus 1 over 2a squared minus a. Then factor each side, 2a minus 1, 2a plus 1 over, take out a and 2a minus 1. Then cancel the common factor. A plus 1 over a, and then put 1 over 2 into a. 2 times 1 over 2 plus 1 over 1 over 2. So this is 1 plus 1, which is 2 over 1 over 2. This one is the same as 2 divided by 1 over 2. And then change the times in upside down, 2 over 1, and make a fraction. This is 4 over 1. The answer is 4. Or This is 2 over 1 over 2. So make a numerator into a fraction by putting it over 1 like this. And then outside over inside. So outside over inside is the same answer. This is the next question. We need to find the conjugate for the numerator and the denominator. The conjugate for the numerator is square root of x plus 1 plus square root of 2x plus 1 over same thing. The conjugate for the denominator is square root of 4x plus 5 plus square root of 3x plus 5 over square root of 4x plus 5 plus square root of 3x plus 5. The limit as x approaches 0. In the numerator, expand these two binomials. So square root of x plus 1 squared minus square root of 2x plus 1 squared, but keep the last one as is. Over, in the denominator, expand these two. So square root of 4x plus 5 squared minus square root of 3x plus 5 squared, but keep the middle one as is. So square root of x plus 1 plus square root of 2x plus 1. Limit as x approaches 0. Simplify. X plus 1 minus 2x plus 1 over 4x plus 5 minus 3x plus 5 times, and keep the second fraction. Then expand x plus 1 minus 2x minus 1 over 4x plus 5 minus 3x minus 5, and keep the second one. Then limit as x approaches 0, and then simplify. Cancel 1 and minus 1, and x minus 2x is minus x over 5 and minus 5 cancelled, 4x minus 3x, which is x, and keep the second fraction. Then cancel the common factor, which is x, and put 0 into x. Its minus is here, so minus square root of, when x equals 0, so square root of 5 plus square root of 0 plus 5 is 5 over square root of 0 plus 1, which is 1, square root of 0 plus 1, which is 1. And then minus, this is 2 square root of 5 over 1 plus 1, which is 2. Cancel out. So the final answer is minus square root of 5. Here is the next question. It uses the same method as question 3 to solve. Pause the video and see if you can solve it yourself. Got it? Let's check it together. We need to find the conjugate for the numerator and the denominator. The conjugate for the numerator is square root of x plus 2 plus square root of 3x minus 2 over square root of x plus 2 plus square root of 3x minus 2. The conjugate for the denominator is square root of 5x minus 1 plus square root of 4x plus 1 over square root of 5x minus 1 plus square root of 4x plus 1. The limit as x approaches 2. Now let's multiply. Expand these two. So square root of x plus 2 squared minus square root of 3x minus 2 squared. But keep the last one as is. Square root of 5x minus 1 plus square root of 4x plus 1 over, in the denominator, expand these two binomials. So square root of 5x minus 1 squared minus square root of 4x plus 1 squared, and keep the middle one as is. Then limit as x approaches 2, expand x plus 2 minus 3x minus 2 over 5x minus 1 minus 4x plus 1 times, keep the second fraction, 5x minus 1 plus 4x plus 1 over square root of x plus 2 plus square root of 3x minus 2. Limit as x approaches 2, then expand x plus 2 minus 3x plus 2 over 5x minus 1 and minus 4x minus 1, and keep the second one. Then simplify. The first fraction becomes x minus 3x is minus 2x plus 2 plus 2 plus 4 over 5x minus 4x, x minus 1 and minus 1 minus 2, and they keep the second fraction. And we can factor the numerator, take out minus 2 and x minus 2 over x minus 2, and then second fraction. And then cancel the common factor. Then put 2 into x. So minus 2 is here, times square root of 5 times 2 minus 1, which is 9, plus square root of 4 times 2, 8 plus 1, another line, over square root of 2 plus 2, which is 4, plus 3 times 2, 6 minus 2, 4. So 2 times 3 plus 3 over 2 plus 2. So minus 2 times 6 over 4 is minus 2 times 3 over 2. Then finally, your answer is minus 3. This is the next question. It is similar to question 3 and 4. Again, we need to find the conjugate for the numerator and the denominator. The conjugate for the numerator is square root of 5 minus x plus 2 over square root of 5 minus x plus 2. The conjugate for the denominator is square root of 10 minus x plus 3 over square root of 10 minus x plus 3 equals limit as x approaches 1. Expand these two numerator. So square root of 5 minus x squared minus 2 squared times, keep the last one as is, over, expand these two binomials, square root of 10 minus x squared minus 3 squared, but keep the middle one as is, the square root of 5 minus x plus 2. And then expand. So 5 minus x minus 4 over 10 minus x minus 9 times, keep the second fraction, and then simplify. 5 minus 4 equals 1 minus x over 10 minus 9, 1 minus x, and same fraction like this, and then cancel the common factor and put 1 into x. So square root of 10 minus 1, which is 9, square root of 5 minus 1, which is 4, plus 2. This is a 3 plus 3 over 2 plus 2. So 6 over 4, which is 3 over 2. So the answer is 3 over 2. Here is question 6. Once again, we need a conjugate for the numerator and the denominator. The conjugate for the numerator is square root of x minus 3 plus 1 over square root of x minus 3 plus 1. Then conjugate for the denominator, square root of x plus 2 over square root of x plus 2. So limit as x approaches 4. In the numerator, expand these two binomials, square root of x minus 3 squared minus 1 squared. Keep the last one as is. Expand these two binomials, square root of x squared minus 2 squared, and keep the middle one as is. And then simplify the first one, x minus 3 minus 1 over x minus 4, and keep the second one. And then this is x minus 4. So cancel the common factor. So limit becomes this one. And put 4 into x, square root of 4 plus 2 over square root of 4 minus 3, which is 1 plus 1. So 2 plus 2, which is 4, 1 plus 1, 2. So the final answer equals 2. This is the next question. It is in the 0 over 0 form. As you can see, it has a complex fraction in the numerator. Therefore, we need the least common multiple in the denominator to make a single fraction. So the least common multiple is 2 times square root of 3 plus x. So the limit as x approaches 1 and expand 2 square root of 3 plus x over square root of 3 plus x minus 2 square root of 3 plus x over 2 over, don't expand the denominator part, x minus 1 times 2 times square root of 3 plus x. And then simplify, cancel, 2 minus, cancel, square root of 3 plus x over 2 times x minus 1 times square root of 3 plus x. The question remains in the 0 over 0 form with the square root. Now we must multiply the conjugate of the numerator to get rid of the radical. So times 2 plus square root of 3 plus x each side. And then expand the numerator. So this is a minus b and a plus b form. So a squared, 2 squared minus b squared, which is square root of 3 plus x squared over, don't expand the denominator, so 2x minus 1 square root of 3 plus x times 2 plus the square root of 3 plus x. And then expand the numerator is 4 minus 3 plus x over 2 times x minus 1 square root of 3 plus x times 2 plus square root of 3 plus x. Expand the numerator, 4 minus 3 minus x, which is 1 minus x. And then limit as x approaches 1. The numerator is 1 minus x, but can be written as minus x minus 1, 2 times x minus 1 square root of 3 plus x times 2 plus square root of 3 plus x. Then we can cancel the common factor, which is x minus 1. So it's minus 1 left over. 2 times square root of 3 plus x times 2 plus the square root of 3 plus x. And then put 1 into x. So minus 1 here, and 2 times 3 plus 1, which is 4, times 2 plus the square root of 3 plus 1, which is 4, minus 1, 2 times 2, 4 times 2 plus 2, which is 4. So the final answer is minus 1 over 16. This is the next one. It uses the same technique as question 7. We need to least count multiple in the denominator of the numerator to make a single fraction. That number is 2 times square root of x minus 1 then multiply to each side. So first one, 2 square root of x minus 1 over square root of x minus 1 minus 2 square root of x minus 1 over 2 over 5 minus x, don't expand the denominator, 2 times square root of x minus 1. And then simplify 2 minus square root of x minus 1 over 2 times 5 minus x square root of x minus 1. This question in the 0 over 0 form with the square root again. Find the conjugate of the numerator, which is 2 plus square root of x minus 1 over 2 plus square root of x minus 1. Then expand the numerator. A minus b, a plus b form, so a squared minus b squared, and don't expand the denominator part. 2 times 5 minus x square root of x minus 1 times 2 plus square root of x minus 1. And then simplify numerator. 4 minus x minus 1 over 2 times 5 minus x square root of x minus 1 times 2 plus square root of x minus 1. The numerator is 4 minus x and plus 1, which is 5 minus x. So limit as x approaches 5, so numerator is 5 minus x over denominator is 2 times 5 minus x square root of x minus 1 times 2 plus square root of x minus 1. And then cancel the common factor. So limit as x approaches 5, 2 times square root of x minus 1 times 2 plus square root of x minus 1. Numerator is 1. And then put 5 into x. So 1 over 2 times 5 minus 1 is 4 times 2 plus square root of 5 minus 1 is 4. 1 over 2 times 2, which is 4 times 2 plus 2, another 4. So the answer is 1 over 16. This is the last question. When x approaches 3, the denominator equals 0. Since the answer of the limit is 2, the numerator must also equal 0 to create the 0 over 0 form. Let's set it up. So limit as x approaches 3, a square root of x minus 2 plus b equals 0. Then put 3 into x. So 3 minus 2 equals 1 plus b equals 0. So a plus b equals 0. Do you remember the last question in the typical set of the limit by factoring video? When there are two variables in the problem, there must also be two equations like a system. Since there is only one equation here, one of the variables must be solved for first. Look at the original equation. X is the variable while a and b are constant. In this case, b is simply a constant versus a which is tied to the radical. That's why we solve for b first. It is easier. Therefore, b equals minus a. Now, we will put b equals minus a into the original limit. So the limit becomes a square root of x minus 2 plus b, but b equals minus a. So minus a over x minus 3, and factor the numerator. Take out a, and square root of x minus 2 minus 1 over x minus 3. It is in the 0 over 0 form with the square root. Multiply the conjugate of the numerator on each side. So times square root of x minus 2 plus 1 over square root of x minus 2 plus 1. The limit as x approaches 3, so expand the numerator, square root of x minus 2 squared minus 1 squared over, don't expand the denominator part, x minus 3 times square root of x minus 2 plus 1 equals, expand the numerator, x minus 2 minus 1 over x minus 3 times square root of x minus 2 plus 1. And then cancel the common factor, which is x minus 3, x minus 3. So this one is left over. And put 3 into x is a over square root of 3 minus 2 is 1 plus 1. So is a over 2. But this is left side, must be right side, which is 2. And then make a fraction and cross multiplication. So a equals 4. And then now go back to p equals minus a here. So we get p equals minus 4. Therefore, a equals 4 and b equals minus 4. I hope this video has been helpful. This is the last 3 videos covering the limits with the square root. Look at the calculus playlist for the previous videos. Thank you for watching. Please like and subscribe for more.